My dear students, very good evening. Uh, I am paying you headboard salutations for your support and encouragement. And please, I am requesting you all subscribe all my videos. Thank you. Now today we are going to do eigenvalue problem. Eigenvalue and eigenvectors of a square matrix. And example 2. Already one example yesterday I posted you, uploaded you in the YouTube. Please go through it. And this is second example. And if A equal to square matrix 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5, then find all the eigenvalues and corresponding eigenvectors. This is coming for 7 or 8 marks, and in some universities 10 marks it is coming. Solution. By the data, A is given by examiner 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5. Now, first of all, you have to find out characteristic equation. A. The characteristic equation is given by the determinant of A minus lambda I equal to 0. In most of the books, this is a formula given. But it will take more time to get the values, and simplification takes a lot of time. Therefore, I am using the shortcut method. Shortcut method is given by lambda cube minus lambda square sum of D means sum of diagonal elements plus lambda sum of MD means minors of diagonal elements minus determinant of A equal to 0. Then you have to find out this summation of D. Okay, summation of D means diagonal elements sum. Look here, 7 plus 6 plus 5. You can add simply diagonals. 7 plus 6 plus 5, 18. You got value of the, look here, lambda square. Then the MD means minors of diagonal elements, means the determinant. Look here, minors means the second order determinant. Look here, minors of 7. You leave this, close this column, close this row. The whatever things remains are minor. 6 minus 2 minus 2 5. 6 minus 2 minus 2 5 plus minors of this 6. You close this row, close this column. 7 0 0 5. 7 0 0 5. And minors of 5. You close this row, close this column. 7 minus 2 minus 2 6. 7 minus 2 minus 2 6. And this is second order determinant. Anybody can do it without much difficulty. 6 into 5 30. Minus of minus plus. Upward journey minus. Plus into minus minus. 2 into 2 4. Then 7 into 5 35. Minus 0 0 into 0 0. Plus 7 into 6 42. Minus of minus plus. Plus into minus minus. 2 into 2 4. Then simplification. 30 minus 4 26. 35 minus 0 35. 42 minus 4 38. If we add all those things, you can get 99. Okay. Then next, third, the determinant of A equal to determine the matrix determinants you have to write 7 minus 2 0 minus 2 6 minus 2 and 0 minus 2 5 equal to 162. How to get 162? I am telling you. Look here. I am using the calculator 991 ES plus. On the calculator, the press the mode button. Look here, this is, you create the matrix. Okay. Then you press the 6th button. And I want to store this in the matrix A. Means you press the 1 button. And it asks the dimension. This is 3 by 3 matrix. Therefore, press the 1. Then look here. On the calculator display, such a dialog box is opened there. Okay. Now, look here. Cursor is here. Okay. Now, 7 equal to button, minus 2 equal to button, 0 equal to button, minus 2 equal to button, 6 equal to button, minus 2 equal to button, 0 equal to button, minus 2 equal to button, 5 equal to button. You entered all these values in this matrix. Then look here, and AC button. And then shift and matrix is at the number 4. You press the fourth button. Then matrix is coming. Then what I want? We want a determinant. You press the 7th button. Look here. On the display of calculator, DET bracket is coming. Then determinant of what I want? Matrix here. Again, shift, fourth button, and where the matrix is at the third. If you press the third button, look here, you get the mat A. Mat A. And close the bracket equal to button. You are getting 162 on the display of calculator. You write it. Then look here. Now you put all these values in the characteristic equation. Lambda cube minus 18 lambda, summation of diagonal elements 18. Look here, summation of diagonal elements 18. They look here, lambda cube minus 18 lambda square and MD, the 99 lambda minus determinant. And determinant is 162. Okay, you write that. See here, I have written lambda cube minus 18 lambda square plus 99 lambda minus 162 equal to 0. And actually, you have to factorize and find the values of lambda. That is very, very lengthy process, and you are wasting lot of time. Then I will give you the shortcut method. And this is a cubic equation, ax cube minus bx square plus bx square, and plus cx plus d equal to 0. Then in calculator, you can find out this value. Then you press the on button and mode button, and this is a equations, means you press the fifth button. And this is cubic equation. This is a fourth one and fourth button. Look here, such a dialog box is opened there. Then the cursor is here. Then look here. The coefficient of lambda cube 1. 1 equal to button. And cursor comes here. Then look here. Coefficient of lambda square minus 18 equal to button. And cursor comes here. Then coefficient of lambda 99 equal to button. Then cursor comes here. Then minus 162 equal to button. Minus 162 equal to button. Then you press again equal to button. You are getting on the display of calculator x1 equal to 3, x2 equal to 6, and x3 equal to 9. And these are the Eigen values, my dear students. Okay. Then whether these Eigen values are correct or not, in exams are not necessary to verify, but in class you can verify. Then verification of Eigen values. Then by the properties of Eigen values, you can verify. Summation of lambda equal to summation of diagonal elements. And the product of Eigen values equal to determinant of A. This is a property of Eigen values. And look here, summation of Eigen values, lambda 1 plus lambda 2 plus lambda 3 equal to summation of diagonal 7 plus 6. Look here, 7 plus 6 plus 5 and 3 plus 6 plus 9. You can add them, 18 equal to 18. Means your Eigen values are correct. And one more test for this. The product of lambda means lambda 1 into lambda 2 into lambda 3 equal to determinant A. Determinant A value is here only 162. Then lambda 1 3 into 6 into 9 and multiply 162 means correct only. Only check, only by means of one formula you check it. That is all. Okay. This is give the confidence part. Then next. This is very, very, very important step, my dear students. We form the system of equations as follows. Look here. This is here. 7, this is X column, this is Y column, this is Z column. Look here. Along with the diagonal elements, you take minus lambda. 7 minus lambda into X, 6 minus lambda into Y, 5 minus lambda into Z. You have to write. And these are all X and Y. Okay. Now, look here. Same thing I have written. 7 minus lambda into X minus 2Y plus 0Z equal to 0 minus 2X. 6 minus lambda Y minus 2Z equal to 0. 0X minus 2Y plus 5 minus lambda Z equal to 0. This is equation A. Now, look here. Lambda, how many lambda values we are having? 3 lambda values. You can put 3 values lambdas in this equation A. Then, in case number 1, if lambda equal to 3, then equation 1 becomes, you put lambda equal to 3. 7 minus 3, 4x minus 2y and 0z. And here minus 2x and 6 minus 3, 3y and minus 2z equal to 0. And 0x minus 2y, 5 minus 3, 2z equal to 0. And these are equations 1, 2, 3. You take any two set of equation and apply the cross multiplication. I am taking 1 and 2. You can take 2 and 3. You can take 2 and 3. You can take 1 and 3. It all left to you. Answer is the same. Then look here. I am taking 1 and 2, applying the cross multiplication. Look here. X divided by determinant minus 2, 0, 3, minus 2. Minus y. It is minus is there, that is why minus. No. Always you take with the minus y. Divided by determinant. 4, 0, minus 2, minus 2. Look here. And z divided by 4. Look here. You keep the pencil here and take the coefficient of remaining variables. 4 minus 2, minus 2, 3. Look here. X upon minus 2, 0, 3, minus 2. Minus y upon 4, 0, minus 2, minus 2. Z upon 4 minus 2, minus 2, 3. And here 2 into 2, 4. And this is 0. And y 4 into minus 2, minus 8. And this is 0. Look here. Z 4 into 3, 12. Minus of minus, plus, plus into minus, minus, minus of 4. And simplification gives x upon 4, y upon 8, z upon 8. And here 4 is a common. Take out common. It becomes x upon 1, y upon 2, z upon 2. Very, very great work, my dear students. We got the eigenvector. X1 eigenvector equal to, look here, 1, 2, 2. 1, 2, 2. And this is transpose. Actually, it will be in this form. But for printing purpose, it takes more space. That is why they have made it as a transpose. Okay. Then is the corresponding eigenvector for the lambda equal to 3. Similarly, case number 2. Put lambda equal to 6. Then equation A becomes, look here. Put lambda equal to 6 in this equation. 6. 7 minus 6. 1x minus 2y plus 0z. 2x minus 6 minus 6 means 0. 0y minus 2 equal to 0. 0x minus 2y. And 5 minus 6 minus z. You have to write. Look here. Same. X minus 2y plus 0z equal to 0. Minus 2x plus 0 minus 0y minus 2z equal to 0. And 0 minus 2y minus 1z equal to 0. You take any two equations and use the cross multiplication. You can take 4, 5 and 4, 6, 5, 6. You can take any two. Answer is same. Look here. X divided by these values minus 2, determinant of minus 2, 0, minus 0 and minus 2. Divide by. And minus y divided by 1, 0, minus 2, minus 2. Look here. Here. Then z upon, look here. 1 minus 2, minus 2, 0. Z upon 1 minus 2, minus 2, 0. And simplification. This is second order determinant. X upon 4 minus 0 means 0 only. Then minus 4 divided by minus 2 and again this is 0. And z divided by 0. Look here. This is 1 into minus 0, minus 4, and z upon minus 4. And simplification gives you look here, this is getting cancelled. Minus is here, minus is getting cancelled. X upon 4, y upon 2, z upon minus 4. And 2 is a common. Take out 2 common. X upon 2, y upon 1, z upon minus 2. And this is the Eigenvector, my dear students. Okay, look here. X2 equal to 2, 1, 2. And this is actually transpose it is. And actually it is in this form is the required eigenvalue for the lambda equal to 6. And if lambda equal to 9, then equation A becomes, look here, 9. 9 means here, look here, 7 minus 9, minus 2x, minus 2y plus 0z, minus 2x, 6 minus 9, minus 3y, minus 2z equal to 0. 0x minus 2y, 9 minus 5 minus 9, minus 4z equal to 0. Look here. See. This is, see here. This is. Then lambda equal to 9, equation becomes minus 2x, minus 2y plus 0z equal to 0, minus 2x minus 3y minus 2z equal to 0, 0x minus 2y minus 4z equal to 0. Then you take any two equations and apply the rule of cross multiplication. You can take 7, 8 or 7, 9, 8, 9. You can take any two. The answer is same. Applying the rule of cross multiplication for 7 and 8 means you put the pen here divided by, look here, minus 2, 0, determinant of minus 2, 0, minus 3, minus 2, minus y divided by minus 2, 0, minus 2, minus 2. And look here, z upon minus 2, minus 2, minus 2, minus 3. Look here, x upon, these are minus 2, 0, minus 3, minus 3, minus 2, minus y upon, look here, keep the pen here, you can write, and these things. And keep the pen here, you can write these things here. And simplification gives you the 2 into 2, 4, and 0 it is 0, minus y, and this is plus 4, and this is again 0. Then z upon, look here, minus into minus, plus, 3 into 2, 6, minus into minus, plus into minus, minus, and 2 into 2, 4. And simplification gives you x upon 4, then y upon minus 4, because I am shifting this minus to the denominator. Z upon 2. 6 minus 4 is 2. Then 2 is a common here. Take out a 2 common. And x upon 2, y upon minus 2, z upon 2. This is the Eigenvector, my dear students. Look here. X3 equal to 2 minus 2, 1 transpose. Actually, it is in this form. 2 minus 2, 1. This is the corresponding Eigenvector for the lambda equal to 9. This verification, in the example, not necessary. In a class, you can do whether your eigenvalues are correct or not. Then this can be verified by the property of eigenvalues. Or as the eigenvalues are orthogonal to each other, means they are perpendicular to each other. If the two vectors are perpendicular, in PUC you have studied multiplication, the dot product of any two perpendicular vector equal to 0. x1 dot x2 equal to 0, you are getting, and x2 dot x3 equal to 0, or x3 dot x1 equal to 0. How to this verification? You can do it in calculator. Then look here, on the calculator, press the mode button. These are vectors, means this is 8. Okay, 8. Then we have to create the vector A, means press the 1. Look here, this is what A. Then you can enter here. The A you have to create means press the 1. The A and again 1 means such a dialog box is coming there. Cursor is here. Then here, look here. 1 equal to button, 2 equal to button, 2 equal to button. Look here, 1 equal to button, 2 equal to button, 2 equal to button, AC. Then again, shift and vector means a fifth button, and press the 1 dimension. And where you want to store this x2? In B. Okay, vector B, and press the 2. And what is the dimension of 2? this is 3. Then means you press the 1. Such a dialog box is opened there. Then 2 equal to button and 1 equal to button and minus 2 equal to button. Look here, 2 equal to button, 1 equal to button, minus 2 equal to button, AC button. Then again shift, again vector. Then again press the dimension. Then where you want to store the x3 in C, then you press the third button. And what is the dimension? This is 3 means 1. Again such a dialog box is opened there. And 2 equal to button, minus 2 equal to button, and 1 equal to button, and AC button. Look here. You want to find out the A dot B. You want to find out. This should be 0. Means x1 in dot x2 equal to 0. Then look here. Shift and vector. What you want? A means 3. Then shift and vector and dot product I want. Press the 7. Means look here. In the other calculator, the VCT A and dot is coming. Then again shift, again vector, fifth button. What I want? The vector B means 4th. Then on the display of calculator, VCT B and press equal to button. 0 you are getting. Then after bringing this, look here. Vector A dot vector C I want to take. Look here. Vector A dot vector C. And you press the arrow button. Then arrow comes here. Okay. Then you press the delete button. Then delete. Then in this place, what you want to bring it? Vector C. Again, shift vector C, where it is? 5. Then vector C has come and 0. Then vector A dot vector C, 0. Then you bring the cursor here and delete this. You bring the vector B here, and that is also 0. In this way, you can make a verification. This is for your information, not for examiner. Okay, my dear students. In this way, you have to solve these problems. Have a nice time, good day. And it is my humble request, please subscribe all my videos. Thank you, my dear students. Have a nice time, good day.